All right, today we're going to talk about Linux orphan processes. So when a parent process exits but the child process keeps running, it will be orphaned. So it is adopted by init or systemd or whatever your init system is, and its PPID or parent process ID will become 1. So the PPID of the child process will become 1 when it's adopted, and this allows the child process to finish running and to clean up. These orphan processes are usually not harmful, but they can indicate a bug because, if the parent process finishes and closes before the child process is done, that's probably not how a program was designed to run, right? It's probably that's just not how they're normally meant to work. You're generally meant to wait. Anyways, so if you do spot something like this in the wild, it's something to look at. You might want to investigate it and see what is probably going wrong with the program, with whatever server or script caused this to happen. So anyways, let's take a look at an example of how a child process might be created. So let's take a look in our current directory. We have one file, a C file. Let's edit this. We're not going to really edit it, just look at it. So we have some include files, some header files included here, nothing important, so ignore that. So we have we're calling fork, right? And fork will split the process into two child processes, or rather into two processes, one the parent and one the child. And the child process begins running right at the next line, right after the call to fork, right? And the difference between the child and the parent is the fork function call will return the PID of the child process to the parent process. So the parent process will receive the PID of the child process in the PID variable right here, whereas the child process will just receive a value of 0 in this variable. So we test here if PID is over 0, we know we're in the parent process. Else if PID equals 0, we know we're in the child process, right? The child process has a 0, whereas the parent process gets the PID value of the child process, right? So if we have a parent process, we're going to call exit 0 to exit with no error, exit successfully, but we're going to just exit the process, right? So the parent process exits, and the child process will continue on sleeping for 3,000 seconds until it will eventually call exit. But during that time, it will be an orphan. So normally, the child process would normally have a PPID of the parent process's PID. The parent process's PID will be the PPID of the child process. So if you kill the parent process, the child process is going to be adopted by systemd, and which has a PID of 1, so the parent process of the child process will be 1, and we'll show you that in just a second. But first, let's go ahead and compile this. So gcc test.c -o, and we're just going to call this test, and I think that's good enough. We'll just call it test, right? So there we go. We have our source code and our binary right here. So let's go ahead and let's see what's running right now. Not much running in our current shell. So we're going to run test. Now immediately the parent process dies and the child process keeps running. So let's verify that. PS. And you see here, we see one process running. The command is test. That's the one we just ran. It's going to be running for 3,000 seconds. So let's run it with some full output right here, ps-f. And we're going to see that our command that we ran, test, has a PID of 4111 and a PPID of 1. Now, just in case you're curious, ps-ef, let's just show you what's at the top here. If you see sbin init, that has a PID of 1, and sbin init should point to probably another thing, which is systemd, just in case you're curious. There. So sbin init points to systemd right here. So this is PID 1 is systemd. So the PPID of our test program is systemd. So our test program is running directly. It has been adopted by systemd. That is our orphaned process. So basically, this is it, our orphaned process right here. Now, we could create a lot of them if we want to. Run test. So ps-f will show us a whole bunch of processes. So when you see a whole bunch of processes under running under with a PPID of 1 under System D, unless those are top level daemons. In a lot of cases, there might be some top level daemons, but usually if they're not supposed to be, there's a good chance that these are orphan processes, and you might want to let them get cleaned up naturally, or if there's something that there's too many of them, they're using up too many resources, their system's running out of memory, or you just happen to know because you're familiar with the application and you know that they don't need to be running, you might just go ahead and kill them all, right? So yeah, there's that, but otherwise not a whole lot to worry about other than looking at what your what the root cause of this is. You might look at the code and fix the problem, tell it, make sure that your parent process waits for your child processes to finish. Now, if you're on PSEF, you're going to notice there are other processes with a parent of 1, like GPG agent. This is just a top level service running, and like UPowerD, stuff like this. These are all running directly under System D. So it doesn't mean anything running directly under System D is is an orphaned process. These ones are intended to be running there. They're running as daemons. They're running as services, top level services directly under System D. So there you go. Hopefully that was helpful. And if I left anything out or forgot anything, or any questions, comments, or criticisms you have, feel free to leave a comment down below, and make sure to give me a thumbs up. And that's about it for today. So make sure you do hit that subscribe button and the bell icon, to make sure you don't miss out on our other great content we have. We have a lot of other great content. We do, a lot of code, a lot of Linux stuff, a lot of Windows, Mac OS stuff too. We do hardware, software, servers, networking, Raspberry Pis, 3D printing, lots of great tech stuff. So make sure you hit that subscribe button. And that's about it for today. So thanks for watching, and we'll see you guys on that next video.